Now, on our test, we don't have to play with the moving man. On our test, we have to solve problems. And so let's get to some actual problems. So what do we have here? Now, we're not given the man, but we're given the position versus time graph. And so knowing what you now know, what does this mean? Well, first of all, it's a slope. It's a positive slope, and that means the man is moving. Where does the man start? At position 0 and time 0, and where does the man end? At position 6 and at time 3. So what did the man do from here to here? The man walked, and walked with a constant velocity. Now the cool thing is that we can actually use the slope of this line to figure out how fast the man is walking. So what's the rise in this? Well, it goes from 0 to 6, and so the rise is going to be 6 meters. What's the run? It goes from 0 to 3, and so that's going to be 3 seconds. And so the velocity in this case is actually 6 meters per 3 seconds, or 2 meters per second. Now, we learned in the last podcast that velocity is position final minus position initial over time final minus time initial. And that's all we're doing in slope. In other words, the slope of this line is giving me the velocity of that object. So to solve that in a more roundabout way, let's kind of go down to this next one. So let's go right here and figure out the velocity of the man here. Well, if we look down here, the final position is 3 meters. The initial position is 6 meters. The final time is 8 seconds, right here. And the initial time is 5 seconds. And so this should be -3 meters divided by, well, 8 minus 5 is 3 seconds. And so during this period of time, the speed of the man, or velocity, is -1 meters per second. And so our speed here was 2 meters per second. Our speed here is 0 because the man's not moving again. And then down here it's -1 meter per second. And then finally it's 0 again. And so if we clear this off, again, a goal was to be able to graph that. So I'm going to graph this as, put this as 0 velocity right across the middle. And so from position 1 to position 3, so from position 1 to position 3, what was the velocity? The velocity was, and let's make this 1 and make that 2 on our scale. So from here to 3, the velocity was actually 2 meters per second. It's going to be a straight line. Now, what was the velocity from this period? So from period 3 to period 5, so time 3 to time 5, is actually 0. So I'm going to draw a straight line right across here, and then you can connect that with a vertical line like that. It should be straight vertical. Okay, so the velocity was 2 meters, then it was 0 meters per second. What was it during this period of time? We just calculated it. For the next 3 seconds, 1, 2, 3, it was -1 meter per second. So 1, 2, 3. It was -1, so we'll call this -1 right here, and this would be 1. And then what was it at the end? At the end, it was 0 again. And so this would be the velocity versus time graph for that object. It was going a constant speed in the positive. In other words, the moving man was moving to the right. He then paused for a little bit of time. He then went in the opposite direction, not as fast. You can see that the slope of the line is not as steep as it was over here. And then the man waited for a period of time. And so that's how you'd go from a position versus time graph to a velocity versus time graph. And the easy way to do that, position versus time to velocity versus time, is just to figure out the slope. Because if you figure out the slope of the position versus time graph, that'll always tell you the velocity versus time graph. If that doesn't make sense, go play. It's phet.colorado.edu. Play with the missing man or the moving man and then take a stab. Now, if you play around a little bit, what you're going to find is that it's not always as straight. In other words, when we were doing it, Moving Man was moving straight to here and then resting and straight to here and resting. But in this graph, you see that it's actually a curving line on the velocity. And what that means is, or on the position versus time, and that means that its velocity is changing. So you could try to figure out what the velocity versus time graph is, or you could watch Position versus Time Part 2, and I'll give you some tips. So I hope that's helpful.